Hello, and welcome to Math Matters. I'm Dr. Jameson, and today we're going to learn how to solve multi-step problems involving area. For this lesson, you will need paper and a pencil, or something else to write with. We will pause while you take a moment to gather those materials. Welcome back. Now that you have your materials, let's get started. What is the same and what is different? Take a moment to jot down your ideas or tell someone who's sitting next to you. You may have noticed that bow shapes can be decomposed or broken apart into other shapes. You may have also noticed that bow shapes could be broken into a triangle and a quadrilateral. Now let's look at what's different. Although both shapes can be broken into a triangle and quadrilateral, shape A is composed of a right triangle and a square, and shape B is composed of an obtuse triangle and a rectangle. Let's dive into what decompose means. When given one figure, you can draw lines to break it apart into smaller figures. Let's look at these figures and think about how we might decompose them or break them apart. Take a look at figure A. How might you decompose it to help you find the area? You might have decided to draw a vertical line here and break it into a rectangle and a square. Or you might have decided to draw a horizontal line here, which also results in a rectangle and a square. Additionally, you could have decided to draw both of those lines like this and decompose the figure into 3 squares. How did you decompose it? Now let's take a look at figure B. How might you decompose this figure to help you find the area? You might have decided to draw a horizontal line here to break it into a triangle and a rectangle. Did you decompose it the same way, or did you find a different way? And finally, let's look at figure C. This one looks like we may need to split it into more than 2 figures to help find the area. How might you decompose this figure? One way you might choose to decompose it is by drawing 2 diagonal lines. By drawing these 2 lines, we have split this figure into 2 triangles and a rectangle. Now that we have an understanding of decomposing figures, let's see how this can help us solve real-world problems. Take a look at this scenario. Sophia talked her parents into letting her paint one wall of her bedroom bright pink. She needs to find out how large the wall is so she knows how much space she needs to paint. Below is a picture of the wall Sophia is painting. Let's take a closer look at the wall Sophia needs to paint. Sophia measured the wall and found out it had a height of 8 feet. Then she measured the top part of the wall and found out it has a length of 14 feet. After she measured the bottom part of the wall and found out she only had a length of 20 feet. Finally, she measured the length of the diagonal side of the wall and found out that it was 10 feet. Now that Sophia knows the dimensions of her wall, how can we use those measurements to figure out the space or the area that she needs to paint? Sophia realized that she could break up or decompose her wall into different segments to help her find the area. She decided to break the wall into a triangle and a rectangle by drawing an imaginary line like this. Notice that she already had the dimensions to find the area of her rectangle. She knew that if she multiplied the length times the height of the wall, she could calculate the area. So Sophia multiplied 14 feet by 8 feet to get 112 square feet. Next, she knew she needed to find the area of the triangle. She knew the height of the triangle was 8 feet because it was the same height as the rectangle. Then she had to calculate the length of the triangle. She realized that if she took the length of the bottom of the wall and subtracted the length of the top of the wall, it would give her the length of the base of the triangle. She took 20 feet and subtracted 14 feet for it to give her, you got it, 6 feet. Now that Sophia figured out the measurements of the triangle, she realized she had a measurement she didn't need. She decided to get rid of the length of the diagonal side of the wall so she could focus on the information she needed. She knew the area of a triangle would be found similar to that of a rectangle. She could multiply the base of the triangle times the height of the triangle. Then she needed to multiply her answer by 1/2. Since a triangle is half of a rectangle. Sophia then added the area of the triangle, 24 square feet, plus the area of the rectangle, 112 square feet, and got a total area of 136 feet squared that she needed to paint. In today's episode of Math Matters, we learned about how to decompose figures into smaller figures to help us solve real-world problems. Next time, we're going to take a look at a circle and see how that relationship can work out and how we can find it. I'm Dr. Jameson. Hope you have a great day and keep on counting.